In the last lecture, we have created abstract contract called logger, which is declaring one state variable, constructor, function to override, and one function implementation. In this lecture, we'll continue with a similar implementation, but this time we are going to create interface. Interfaces are in some way similar to abstract classes, but they are even more restrictive. All right, so let's start. Let's navigate to our folder of our construct and contracts, and we'll create here a new interface contract, which will provide interface for our faucet contract. So it will state what function we has to implement when we are implementing this particular smart contract. Okay, so in a contract folder, new file, and I'll call it I for interface. Of course, you can call it as you want, but I'm starting with the I faucet, which is stated with this name should tell us that it is the interface. So I faucet.sol. Okay, we'll just copy function headers, or actually contract headers, license, and the contract keyword, and we'll call it I faucet. Perfect. So now what functions we would like to here state that we have to implement when we will be using this contract. I want to state here that our faucets contract has to implement function add funds and withdraw funds. This has to be mandatory for every faucet smart contract. So here I will say in a faucet, I will say here will be function add funds, and this function should be payable. And also I need to mention here that your smart contract, when it's an interface, actually there should be interface. There's a special keyword for this, so interface faucet. When you are setting here interface, all your function have to be external. Your functions have to be external, and this one is also payable, right? So payable, like this. When I will mark it as a public, I should get here error. They have to be external. Okay, so add funds, I will copy paste it, and I will the other one is withdraw, withdraw, and we'll specify here also uint of the withdraw amount. So withdraw amount, and again this will be external function. Okay, and that's it. Basically this is what is stating interface. I'll write a couple of comments for you. They are similar in some way with the abstract classes, but there are some restrictions. They cannot inherit from other smart contracts. Okay, they can only inherit from other interfaces. They can only inherit from other interfaces, from other interfaces. Okay, so that's the first restriction. Second one is they cannot declare a constructor. They cannot declare a constructor. Okay, third one, they cannot declare state variables. They cannot declare state variables. Okay, and all of the functions they have to be external. All declared functions have to be external. Okay, that should do it. Okay, so here we have interface. Now we are going to implement it. So let's go to our faucet. Let's write here import ./i faucet.sol semicolon here, and now we can write here also I faucet. Okay, contract faucet should be marked as abstract. Okay, so one thing here when we are now implementing here also this I faucet, that we have to mark these functions as an override as well. It will be complaining here the function has to be override now, so I will write here override, and also the same to withdraw. Well, actually withdraw, it doesn't state it. Let's write it here also override. Maybe we have an issue with the naming, basically, because now I don't need to have here withdraw. Okay, maybe some namings here. So let's go back to withdraw function here. Let's copy it. Also, let's copy the entire this line here. Let's go to our contract. Okay, function withdraw. That's correct. It is stating the same name, right? Oh no. This should be lowercase d here. Withdraw like this. Now we should be fine. Save it. Let's see here. All right, and it's still complaining about this. Let me remove it. I hope. Oh, now it's complaining about override. So now we can mark it as an override. Okay, now no issues here. It was a little bit delayed. Okay, perfect. Okay, and now whenever you are implementing interface, for example, ifaucet, whenever I will have also other smart contracts, and I will implement the ifaucet interface, and I will start without any advanced function. I'll copy it first and remove it. You will see I will be immediately warned. I'm immediately warned that there is some issues. Contract faucet should be marked as abstract, not very descriptive message, but I know that I have to have here a function advanced, and only then everything will be fine. Okay, and here in the interfaces, I cannot declare here any state variables. I cannot have here function implementations. So this is even more restrictive as with the abstract classes. Okay, there just goes function that I have to implement, nothing more. Okay, so let's save it. Let's verify that everything is working. Basically, we didn't do any hard changes now. So let's go to terminal. I don't even know that we need to do it, but yeah, let's try to remigrate. It's also always good practice to test it out. So truffle migrate reset. We will call contract, and we'll add some funds and we will withdraw. So we'll test only add funds and withdraw functionality. Okay, truffle console. Let's move back to faucet contract. Let's scroll down on the bottom and let's copy here instance. Okay. Deployed. Let's provide some funds. Working. Let's inspect your contracts. Transaction contracts faucet. Okay. Yeah. I can still see here storage, but I can see here balance. So this is working. I can try to withdraw some ether. So let's get here withdraw. Okay, withdraw. Okay, this went over limit. I think I need to remove 1,0, right? So maybe it's over limit 1,0 less. This should be 0.5. This should be also over limit. No, this is okay already. Okay, 0.5 is okay. Okay, well, let's inspect our contract now. Contracts faucet 1.95. Okay, so we have the drop 0.05 ether. Everything is working. We can solve the transactions and so on. So now you have it. How you can inherit other contracts, how you can use abstract classes, how you can use interfaces. Okay, guys, so that's gonna be it from this lecture, and let's continue in the next one.